I didn't believe this result, so I looked it up. And 746 is some secret code for the silver line that's under construction. So that's why it's really short. But I did look at some of these other routes. And yeah, 431 is an express bus. And a lot of these routes have multiple branches, and that's why they vary. So these are the shortest routes, and I think I looked this one up, and it's nothing but it's only a 5-minute ride, brings you from a subway station to an apartment complex. I can look at the longest route by adding in descending order. Okay, so the longest route is Route 34, and then 426, and so on. And these would be your meters. If you look up 34, it goes all the way from Walpole to somewhere in the city, and it has a lot of branches. So that's what contributes to it being so long. So you can do a lot of descriptive stats using length, and you can find the average distance across routes. I won't go into that too much. So those are just simple functions that you can apply to the geometry.
What does that ST stand for in all those functions?
Nobody knows what they stand for.
It's to distinguish this, I think it means that it's standard abiding.
Spatial, well,
Spatial.
some people think it means spatial type, because the OGC defined, they put STs in front of it, but they never really told people what it was. So it has two different meanings. Some people think of it as spatial type. So I forgot what the other one is, standard type or something like that.
So this comes from the fact that there was a time when there was no ST. And having the ST means that it has the blessing of OGC.
But it doesn't really mean that, because we decided to put ST in front of everything. It was easier to find all the PostGIS functions. You knew they started with ST. So.
Okay, and then suppose that I want to ask what is the closest bus route to here? I would do that, where I join my 250 Washington Street, and my closest routes are 92 and 93, which is, they run parallel to each other right down the street. And now, this is something you cannot do now with your regular database, because I'm comparing a line to a point, not 2 points. Now, you just think about how hard that would be to do in a non-spatial database. First, you have to figure out how to store your line, and then you're going to have to extrapolate on, well, how do you draw the perpendicular and, what. But here, look. You can compare a point to a line, the distance.
So is it comparing the distance of a line or a line string?
It's going from the point to the line string. It's dropping the perpendicular.
Okay.
So which is the closest? So what is the closest bus line to me?
The closest line segment of the longer line string.
Yeah.
Yes.
Okay.
Yes.
So it's not necessarily perpendicular, right? It depends. When you say closest,
Closest
Yeah, it has to
perpendicular.
be
Drop
perpendicular.
the perpendicular. Think perpendicular.
So it's basically the shortest distance between your point and the line string.
And it's always the perpendicular that we learn from. Yeah. Okay, so there are the closest bus lines to here. Okay.
That's only true if it's a continuous loop, because if there's an end of a bus line, you could be closest to an end point.
Not only that, you could have an angle in the bus line, and you could end up with some.
Right, you could be closest to a corner point.
Yeah, yeah. So thank you for that, but
You
ignore
need to
it
think
for
about geometry.
don't think too hard. What I do is I look at the result. All right, that's true. I go downstairs, I can get 92. I'm done. Go on. I mean,
Sorry,
if you
guys,
really dig into this, you get corner points and kinks and all those things that don't quite work well. But yeah, I look at the result, makes sense. Go for it. It generally works. All right, let me show you Mass Pike. I have the data for Massachusetts Turnpike, again from the same site. And for that, I'm going to use OpenJump. I could use QGIS, but I just variety. I'll use OpenJump. So I am going to run data store query. The good thing with the OpenJump is I can type queries straight into this. I'll call this Mass Pike. And I am going to select the geometry region from, where's the name of that table? Okay, this is a list of, the table that we downloaded actually has all the major roads in Massachusetts, but I'm going to limit it to road 90. Okay, that's 90. That's, I am going to layer Massachusetts towns on top of it, so you can, that doesn't look like much. So I am going to add a,
You want to do it from data store, like right click on the working folder? Right click, yeah, and add data store.
so same connection, local host. I was going to use the town survey polygons. And okay. All right, so our town is this red thing, and you see Mass Pike running through it. Okay. Towns are polygons. They are aerial. That makes sense. So now I ask a challenging question that you're not going to be able to do in any other database that any non-spatial database that I can think of. Suppose you're faced with this problem. Okay. Suppose that you are faced with this problem. Let's say that there is, they're going to transport natural gas because the harbor here is frozen over. The tanker can't get into, and it's really cold. People need to live. So the government decides to transport natural gas from somewhere out in New York across the Mass Pike to Boston in the middle of the night. A caravan of 20 big trucks that could easily explode. And your job is to find all towns that are within 5 miles of the road, so you can contact their emergency management system should something happen. Visually, what I'm going to first do is I'm going to draw a buffer zone.
Yeah, that one.
No, this one.
Yeah, that one.
Where's the buffer here? So I'm going to add a buffer zone. That's the query, and I'm going to show, I'm going to add a layer. I'm going to add
It's under file.
Okay, so I'm buffering my mass pipe by 8046 meters, which is 5 miles. There's my buffer zone. Okay, now this is hard to do in non-spatial. And then once I have the buffer zone, I can ask, well, which polygon intersects which polygon? Anything that's in this buffer zone constitutes one big polygon. I ask, well, which towns does this polygon intersect? And then those are the people that you have to call. And this, and that query is this one. Okay. This query here. So B is my buffer zone, T is my town from the town survey, and then I am doing an inner join. The key function here is intersection. I'm looking at the place where the geometry of the town intersects my buffer zone. And here are the towns. Okay. Now, to do this, otherwise you will have to pull out a map and do this and measure and figure out what it is. And the problem is, what if they change their mind and it's like twice this, the buffer zone? Well, all you have to do is change that to like a 16, which is 10 miles or so. And you should get more towns that's included in this buffer zone. Okay, so this is the type of queries that you can easily run in PostGIS. I did it and just set up and run, and you can. I can't imagine how you do it without the spatial database. So this is the power. So that's it for the vector. I'm going to show you a few things with rasters.
With the vector types, just merely importing this data, is it creating indexes or?
Yeah, we didn't show you that. Under the options, the default is checked to create the index, but you have to click on the options button if you want to uncheck it. So by default, it creates the spatial index.
Okay, and for types like where you had the line segment lists, does it kind of explode those and index the individual line segments, or?
No, it just draws a box around it. So it's very simple. It just draws a minimum bounding rectangle around the whole thing.
Cool.
So each will just have.
So for all the stuff you just did, it was all in mass state planes, so it was all in meters, so it's pretty straightforward for like how to calculate distances and stuff. If you're doing stuff on a national basis, do you just like, for each area you're looking at, do you parse out like what the state plane should be, convert everything to state plane there, or do you use like?
No, you will use a spatial reference system that's more suited for the whole nation.
Yeah.
Mass state plane is chosen because it probably makes the state most rectangular.
Right.
But if you're looking, if you're looking the whole globe,
Yeah.
you probably would use just latitude, longitude, and there is.
Right, but like when you get the area in PostGIS that long, it gives you the area in like degrees, which is worthless.
Yeah.
Right.
So,
There's another type we didn't mention.
It's the geography, which is really just.
Which is
that
another
long.
vector type. So there's geometry.
And geography, which is
And geography.
really, when you look at a global scale, it's already taken into consideration
Yeah.
the spherical nature of the Earth. So,
So I want you keep it in native long lat, but it gives you measurements in meters. But
okay.
the downside of it is that it's slower
Mhm.
and it doesn't have a lot of the processing functions
Right.
that you get. So
okay, so,
for national, I usually use National Atlas, which is accurate within like 4 meters or something, and handles most of the US.
so to show raster, We found these dog pictures from National Geographic. We'll post a link to it. Anyway, so there is no user interface, a nice user interface for you to import the raster, but there is a command line, and I'll show that to you quickly. Yeah, let me delete my dogs table. Okay, so no docs table, but it's really easy to re-import using this command line. Raster load, it's a batch file. The key point is this raster to PostgreSQL. And it will take all the JPEGs. And rasters are nothing but JPEGs and TIFFs and PNGs, those types that you're familiar with.
Yeah, there's spatial types of rasters that measure elevation and stuff, but we'll leave that for another.